Hi everyone, welcome back to the channel. So today in this video, we will be talking about virtual threads. So before that, threads in Java. So what are they? How do they work and why do we even care? Whether you are building a basic application or a high performance server, understanding threads can make or break your design. And today we are diving deep into Java threads, operating system threads and virtual threads. Stick around and by the end, you will know more than most developers out there. So let's start simple. So what is a thread? Think of your CPU as a factory and threads as workers. The more workers you have, the more tasks you can handle at once. But there is a catch. The factory has limited space and workers need resources like desks and tools to get things done. So in Java, the threads we create are called platform threads and they are one-to-one mapped to operating system threads. This means that for every Java thread you create, there is an underlying thread managed by your operating system. Those threads are heavyweight. They come up with significant overhead because of the operating system allocates memory for their stacks and schedules them directly. So let's say your system has 8 CPU cores and 32 GB of RAM. If each thread uses 1 MB for its stack, theoretically you could create around 32,000 threads before running out of memory. But in reality, things like heap space, operating system limits, and context switching costs will kick in long before that. So here is how platform threads work. Every Java thread occupies an operating system thread for its entire lifetime. This means that tasks that involve waiting, like input-output operations, keep the operating system thread occupied, even if it's not doing any useful work. So that's wasteful, right?
So here enter the virtual threads. These aren't tied to specific operating system threads. Instead, the JVM manages them like virtual memory, mapping many virtual threads to a smaller number of operating system threads. So here is the magic. When a virtual thread encounters a blocking operation like reading from a file or waiting for a database response, the JVM suspends the virtual thread. The OS thread it was using is freed up and another virtual thread can use it. This is why virtual threads are lightweight. You can create thousands, even millions without overwhelming your system. So now let's connect the dots between the Java and the operating system. In the JVM, thread falls into two main categories, platform threads and virtual threads. So platform threads are one-to-one mapping with the operating system threads, while the virtual threads are managed by JVM, mapped dynamically to a pool of operating system threads. So let's suppose your application uses virtual threads to handle HTTP requests. If each request blocks for 100 milliseconds on average, and you have 1000 concurrent requests, you could theoretically handle this with as few as 10 operating system threads because the threads are reused. So why should you care? Virtual threads shine in applications with loads of input-output operations, like servers. Imagine handling thousands of HTTP requests, each doing database queries or file reads. With the platform threads, you would run out of OS threads quickly. With the virtual threads, you can scale effortlessly. So let's see some code. Here is how you can create a platform thread and a virtual thread. The API is almost identical, but virtual threads lets you create thousands without worrying about the system limits. So when you should not use the virtual threads? The virtual threads aren't a silver bullet. They are not meant for long running, CPU intensive tasks. Why? Because these tasks would still occupy operating system threads, defeating the purpose of lightweight concurrency. So let's get into OS level insights. At the OS level, thread creation is limited by the stack size, which is again controlled by -XSS JVM option. Smaller stacks mean more threads but less room for deep recursion. Thread creation can also be limited by system limits. For example, on Linux, use ulimit -u to check maximum threads. On Windows, it's tied to memory and stack size. So for an example, on a 64-bit Linux system with 8 GB RAM and 1 MB stack size, you might hit limits at around 8000 threads, depending on other allocations. So time for a recap. So here is what you need to remember. Platform threads are heavyweight and tied to OS threads. Virtual threads are lightweight and managed by the JVM. Use virtual threads for high throughput and input-output heavy tasks and not for the CPU intensive operations. So that's it for this video. If you want more in-depth tutorials, hit subscribe and turn on the notifications. See you next time. Thanks for watching.